Now this figure 20-18 deals with overcurrent protection for secondary connections in accordance with NEC 450.6b. Now again, this figure 20-18 comes from Stallcup's Electrical Design Book, Volume 2. Now, again, if you have looked at previous illustrations on these secondary ties, we still have a 2000 kVA transformer and a 1500 kVA transformer with secondary voltage, three-phase 480 volt. The secondary conductors of these transformers are routed to switchgear, connected into the bus, and overcurrent protection is set for the tie systems and then for the bus tie. And the same to the transformer to the right. Excuse me. You have a circuit breaker there that is routed to the limiters, and then you have an overcurrent protection device in the switch gear that's routed to the tie system. Now what we're wanting to do here, or the code really is requiring us to do, is we can set 250% of the secondary amps for these ties here. Now, if you look at the step one, again, step one, we're just finding the full load amps of the transformer, or we're basically what we're doing, kVA times 1,000 divided by the voltage times the square root of 3. So 2,000 times 1,000 divided by the voltage, 480 times the square root of 3. When the math is performed, we come up with 2,406.7 amps. Now, in step two is the application of the overcurrent protection for the tie in accordance with 450.6b. 200% is selected times the 2,406.7 amps. We come up with approximately 6,016.8 amp. So with that value of amperage, we would need a 7,000 amp overcurrent protection device for the secondary tie, and it would be rated at 7,000 amps as shown in the solution. So this figure 20-18 is using 250% times the secondary current of the transformer to select the size of the overcurrent protection device in accordance with NEC 450.6b as in boy.